I like problem 3 because we're estimating the integral from 0 to 1 of f of t to t, and it is a multiple choice question. I like multiple choice questions because then we get to analyze not just one correct answer, but 3 incorrect answers, because that helps us understand what's going on in a particular problem. So let's take a look. Right away, we know it can't be choice number 1. If it's choice number 1, then someone is not paying attention to writing a multiple choice problem. First of all, there's one answer that's negative and the other 3 are positive, and we're supposed to figure out which one is the right answer. It can't be that one, just from a proper test writing standpoint. But there has to be a calculus reason that it's not the first choice. And the calculus reason that it's not the first choice, is that this is saying the definite integral is negative, but this function is positive on the entire interval from 0 to 1. So we would say since f of t is positive on the interval from 0 to 1, the definite integral should be positive. So it cannot be negative 96.59. We do recognize that what we are looking for is the area under the curve f of t and above the interval from 0 to 1. And since f of t is positive, we are expecting that area, or that change, to be positive. The antiderivative, capital F, will be increasing because the derivative is positive. So there should be some positive change. That leaves it down to these 3 positive choices. That's really what we're deciding. Then we look at where f of t is. Now we're going to think about the area. The area under the curve of f of t is less than 100 because we can see that f of t fits underneath the 100 and it stops short of the 1. There's this extra space in here. The function is entirely under the function 100. So that's going to rule out anything over 100. The area that we're looking for fits in that rectangle, that 1 by 100 rectangle. So the area that we seek fits inside the 100 by 1 rectangle. So the definite integral from 0 to 1 is less than 100. So that rules out the 101.35. That's what makes that number different than the other 2 choices. So we're really deciding between 71.29 and 91.26. Then it just becomes a question of what percentage of the area is covered. Is it close to 70% or is it closer to 90%? And there's only, each box here is a 0.1 by 20. So each box is like 2% on the graph. We can't see all the hash marks, so I didn't draw it that detailed. So it looks that it's closer to 100. So the 91.26, it looks like we've got almost all of the area. So now we actually see the 2 that are really what we're deciding between. We're deciding between 91.26 and 71.29. And to me, it looks like we are covering well more, looks to me that we're covering over 90% of the area, not just 70% of the area. So it looks like we're close to 91.26, and that's why that one is going to be our answer. If we were only covering 71.29 would mean we're only covering 70% of the area. and it looks like we're covering more than that. So now we're just saying it looks like we're covering way more than 70. So now we're making a judgment call, and 91.26 is the answer. It's not about just coming up with the answer. It's looking at the other ones and saying why these can't be. The negative 96.59, that one stands out because it's negative. That's just thinking of the meta. That's just ignoring everything about the problem. If I just said it's multiple choice and these were your 4 choices, you immediately throw out the negative 96.59. That is significantly different. That's just weird. Why is there only one? If it was 2 negatives and 2 positives, now that's a decision that you have to make. But with only 1 negative, it's not bad. Any questions? All right, let's pause the video here. I like this problem. It's interesting, even though it's multiple choice. Let's pause the video here and take a look at some more problems.